Welcome back to the Java Full Stack Developer tutorial series. In this section, we are going to dive into a very important topic, understanding how data structures like array list, hash set, and linked list work behind the scenes. We will also talk about set and map and compare two key interfaces for sorting in Java. That is, there are comparable and comparator. First, let's talk about the difference between accessing elements by index and by neighborhood. So for the by index, we have the array list. So let's create an array list like this, and maybe the array list is string with data string, and we can put the list of names and create new instead of it. Alright, and for this we can add some value, name 1 and name 2 example, and to access the element, you can use the method get and put the index you want to access. For example, you want to access the first one, that is the name 1, or you want to access the element, the second element, you put the index 1 like this. And because data is stored in a continuous block of memory, so you can access elements directly by their position. Okay, so this makes retrieval super fast for access, right? But adding and removing element in the middle of the list can be slow because all subsequent elements need to shift positions, right? For example, you have a list of number inside your memory, because the data stored in the continuous blocks memory. So you can imagine that all of these element is on a continuous block of memory. So you can use the pointer to access any element on this in a very fast way. And but when you want to insert a new element, for example, you insert an element from the first. For example, you insert 0 from first, so all the remaining element need to be shifted position. For example, the first in the first array we have this element, and the index for 0 and for 1 is 0, for 2 is 1, and for 3 is 2, right? But now when you add the array with a new element 0 at the beginning, now we need to move all the remaining element 1 unit, right? So now you need to mark element 1 at the position 1 and 2 and 3 and so on like this. So it will be slow, okay? And if in this situation, if you use a linked list string and name, new linked list like this, and you also put name 1 and name 2 like this, and you can get by the index. But now the data structure rely on relationship between elements. Each element knows about its neighbor. For example, the first element will know the neighbor element, that is the second element. And because of that, making insertion of the deletion efficient. But the traversal is lower since you have to move node by node, right? When you need to access the second element, you need to move from the first element instead of point directly from the pointer. And we have another collection named hash set. The elements are hashed, and accessing depend on hash-based neighborhood. It's faster for lookup compared to the linked list, but there's no indexing or ordering. Okay, so now let's move on to set and the map. Okay, so these are essential tools for managing unique element and key value pairs. The first is set string. Set is a collection that does not allow duplicate element. Okay, the common implementations of the set is maybe we have a list of names equal new hash set. Okay, we also have the tree set, and we also have the linked list hash set like this. But now we will create an example with the hash set. Just remember that when using a set, you need to store unique elements like a list of user ID or email addresses. Okay, so when I put the names, the list name, maybe it can be a duplicate, so I can change it to user ID, so it can be duplicated. And for the user ID, we can add something, maybe ID 1 and maybe ID 2, right? ID 2. Now let's print out the user ID list to see. Alright, we have the ID 1 and the ID 2, right? But now when you add the ID 1 again, and you see, because the ID 1 is the same value of the ID of the element of the first element that we added before, so it will be ignored. Okay, so that's it, the set. So what about map? So map is a collection of key value pairs, and now we have a map like a user map. Okay, interface integer string user map equal new. We have some common implementation of the map is hash map and tree map and the linked map. We can use them in the same way because they have they must implement all the method from the map interface, so we can use it with the method, but depend on your what you want to be used. You need to choose whether you use the hash map, the tree map, or the linked map for the better performance. And in this situation, I just use the hash map. And when you need to associate a key with a value, like storing user information, so the key now is the integer, and the value is the name in string. So when you want to put a value, you can use the method put, and the first element is the key, and the keys cannot be duplicated. Okay, so let's put 1 for here, and the first one is name 1, and now for the second you put 2, and you put the name 2. And now when you want to print, you can when you get, you can use the get method and put the key. I put 1 here, and when I put 1, I can get the name 1. Okay, name 1 here, and also for name 2. Be careful, the key is not the index value. Okay, I put 1 here, and it doesn't like the array, so I can put 3 here. Okay, I can put 3 here, and when I get the 3, I also get the name 1. Like this. Okay, so finally, let's talk about sorting with comparable and comparator. Both are interfaces that help you define custom sorting logic, but they are used in slightly different ways. Okay, we have in sometimes you need to sort a list, right? And we have 2 ways. That's the was using comparable, and the second one is using comparator. For the comparable is the interface, right? Comparable. Right, before we use it, we will create an object, person, and you want to if you want to compare in the list of person, you need to implement. If you use the first way, for comparable, you need to implement the interface comparable like this, and you also put the person for this. You can get some confusion about the defining this, but we will learn about this. This is generate. We will learn about it later. But now just follow the syntax. And in the class in person, we can define some attribute, for example, name and the age. And also you need to create a constructor to initialize the attribute value for the object. This name, and this age, each age, like this. And now we need to implement the method from the interface comparable. And to implement, you can click on the person class, and you can see a bold icon, the light or the length icon appear here. You can click on this, and you choose implement method here, or you can manually write it in your class. You can manually you write the compare to, and the ID will get you will generate you the code. So now you just press enter, so it will generate all the code you want to. And for this method, you will return a value in integer. I will print it first. Integer compare, Okay. All right. We have an object for the input, right? And this object will be compared with the person object here. All right. Can you understand this? When we work in the object, we call the method that we are using the compare to method will compare with the parameter person will be input for this method, right? So for the person O, I will compare this with the by the age. I will compare by the age and the older age, like this. This method integer will compare this value. If you can see this method, if the x less than y, it will return you -1, and the opposite, it will return you +1 or 0 in case this value is equal to. All right. And sometimes you don't need to use this class. You can directly compare them. Age and bigger than age, like this. This age. You can do this and okay. This 1 or -1, like this. But in this case, we can use the integer compare for the accurately. Alright, and now we will create a list of person and we will compare. We will sort in the list. Now list person people equal new array list, and now I will put some data for the people, the Alice 25. Sorry, it's new person. All right. And the second one is J32, and another John 23. All right, and I want to sort this. I can use the class collection and dot sort the people list here, because the person he implemented the comparable, so we can use this for short. You can press the control or press the command and click on the method name, so you can see this method will be here. We will see a list here and call the sort method. All right, so let's. Oh, I'm sorry. I need to after compare, I need to print the list so we can see the result people. All right. All right, you can see. Yeah. I think I need to override the toString method to see. Maybe we return the name. All right. Let's run it. Now, as you can see, John, and then Alice, and then Jay. Very interesting, right? And now we will use the comparator. Comparator is also an interface that lets you define multiple sorting strategy. Instead of implementing it in the class, you create separate comparator. So now you can remove the implemented comparator for the person, and you can remove the method here. Okay, now we can use the collection sort for here. You can remove it. And before we sort, we need to use the comparator and put a person, and we can put the name for this comparator is by name, or okay, by age, equal new comparator like this. And you can see inside the interface we also have a method compare, and here we can use the integer again, compare, and put the O1 and age and the O2 age for this. And now we will call the collection again and sort, put the people for the first parameter, and then we'll put the comparator by the age like this. And now let's run it to see. Alright, now we have the same result: John, Alice, and Jade. Okay, so that's a quick diving into assessing elements by index versus neighborhood, the use case for set and map, and sorting with comparable and comparator. And the concepts are fundamental when working with collection in Java. And if you like the video, please like, subscribe the channel. And if you have any question, please comment them to below the comment sections. I will answer you. Alright, that's it for this video. Thank you for watching, and see you.